students, now let us see what is kinetic energy in a very deep manner. Okay, so kinetic energy, as you know, it is related to motion, and every body which is in motion possesses kinetic energy in it. Okay, so here as you can see the example that we are having gun. Okay, and gun is not working if it is not here, like bullet is not inside it. So we have just put a bullet inside this first gun. Okay, now we are not firing it. So right now that bullet in the first part is in stopped manner, or we can say at the rest. So we can say no kinetic energy is available there. Fine. But now when the bullet is get fired here in the second example, so that bullet here are having now kinetic energy. That is because this is get fired with such a speed. So speed related to motion, and if something is in motion is called to be as the kinetic energy is get possessed. Okay, so that is the part of kinetic energy. Yeah, right now we can say that this bullet is having kinetic energy. Okay, so here formula for kinetic energy. Now let us see that. Let a body of mass m moving from rest to the velocity v. Okay, so any body m is here and it is at rest position right now, and now it is going to move and it is moving with the velocity v. Okay, work done by that body will be equal to the kinetic energy. Okay, right? Very obviously, if somebody is not having energy, then how it would be possible then that it is doing some work? So we can say energy is equals to work. Okay, so here the part of energy is what? Here the part of energy is the kinetic energy. So kinetic energy is equals to work. Okay, now given mass of the body is equals to m, initial velocity of the body is equals to 0 because it was at rest position. Okay, and final velocity is v because it is now moving with such a velocity. Okay, m. Okay, so now if we want to find the formula for the kinetic energy, so distance covered, let's suppose, is s, because in the chapters earlier of force and laws of motion, we all have denoted the distance would always be denoted by S alphabet. Okay, so we know that work done is equals to force multiplied by distance. Okay, students, here what we are doing here, we are just trying to find out the work first, then because the work part that is being done by anybody is obviously equivalent to the energy also, because the energy part, that much energy, that much work. If energy is less, less is work. If energy is more, more is work. That is why what we are going to figure out here is just work. So when we are going to find the work, it is automatically suggest us the energy part also, and both of these are having the same SI unit also. Okay, so we have read about the work already, and the formula for the work is the force multiplied by distance. Okay, so now for force, you know, force is equals to mass multiplied by acceleration. Okay, so acceleration here will be the change in velocity. What is acceleration? Change in velocity per unit time. Okay, so time is given to us. Okay, in question also you will be provided with time. Fine, but here we need to find what is acceleration, change in velocity, and if the body is from rest position is moving and gaining the velocity v, so we can say that the change is for v part only, because v minus u and u is 0, so v is only left here. So we can say that from this to this the change is only v. Okay, so mass is given, acceleration is we have figured it out, and distance is s. Fine. So finding acceleration, here you are having such an equation, and for that this third equation of motion, here u is 0. So for that we are having v square is equals to 2 as. Okay, as I have told you, we are just having this v part. So according to the third equation of motion, we can easily find that. That is why we have read that in previous chapter. Okay, so v square is equal minus 0 is equals to 2as and v square is equals to 2as is left. Okay, now so we can say v square divided by 2s is equals to a, because we are now finding the a part only, so that we can put it in the work formula. Again, work done is equals to mass multiplied by acceleration multiplied by distance. So at this place, at the position of A, now let us put this thing here, so that it would be easy for us to find the formula for work done. Here, gaining the kinetic energy. Because of kinetic energy, what work is to be done, that is equivalent to the energy only. Okay, so here we have put the value of A, and that is v square by 2s. Now s to s is get crossed. Okay, so what we are left with? We are left with kinetic energy is equals to half mv square. Okay, like here, let me elaborate it for you. M multiply by v square by 2s multiply by s. Okay, students, so s get crossed with s. So what is it? We can write it like this now. Half, this is in the denominator part, 2 is in the denominator part, it is multiplying, so we can bring it forward. Multiply by m multiply by v square. Together it can be written as half mv square, and that is the formula for kinetic energy, because that is the work done we have found, and that work done is happened due to the energy that we have provided, and that energy is kinetic energy. So we can find anytime the kinetic energy. If we have to find, we can use this formula and find the thing.